to changing the form of the quadratic so that we have it in its factored form. We're going to look at how we can use that factored form to find information about our quadratic, or actually solve a quadratic equation. So when an equation is in factored form, this shows us our x values that make that equation equal 0. And we remember, when we're solving with square roots, we would always get two answers for x. So for example, if our equation was x squared equals 9 and we just took the square root of both sides, we would get x equals 3 and x equals negative 3. Now, if we had a similar y equals equation, or a quadratic y equals x squared minus 9, which is really kind of like the equation x squared minus 9 equals 0, which, if you think about adding 9 here, would really be this equation. This equation, y equals x squared minus 9, would have x-intercepts at 3 and negative 3, because the x-intercepts are where the y value is 0. So when I set this equal to 0, I can actually solve that. So if we think about an equation in its factored form, we could think about like y equals the quantity x minus 1 times the quantity x minus 5. That would actually be shown by this graph here. And what you might notice about this graph is that it has x-intercepts at 1 and x-intercepts at 5. So really, the values that make this 0 are x equals 1 and x equals 5. Now, the reason that is because these things are multiplied together, right? We use an area model if we wanted to change them back to their standard form. We could, but that wouldn't actually be helpful in solving this, because really, if we have something multiplied by something that equals 0, well, what do we know? This could be a number, but then this would have to be 0, or vice versa, right? The first thing could be 0, and the second thing could be a number. So when we have two things that are multiplied together to equal 0, if we figure out what makes each one 0, so like what could make x minus 1 0? What could make x minus 5 equal 0? So then if we just do a quick inverse operation, or you can kind of almost think about it in these cases, we get our two answers for x equals 1 and x equals 5, or the x-intercepts of our graph. So let's take a look at this next one. So this next one's a little bit different because it's not currently in factored form. Now, I could try like, oh, I'm solving by inverse operation, so I'm going to move everything the other side, but this actually isn't a good candidate to solve that way, because you kind of get to this step and then it's like, oh no, I have this x squared and this x, I can't put them together. If I move the x to the other side, I can't square root something with an x in it. So inverse operations is actually not a good way to solve this problem. So I'm going to abandon that tactic. And instead, I'm going to think, okay, let's try to change this to factored form. So can I find, right, what would multiply to 24, but combine to negative 11? So I've got a positive 24 here, and I know those two things are going to combine to negative 11. So 1 and 24, that could never make 11. 2 and 12, that could never make 11. 3 and 8. 3 and 8 could make 11. They could make negative 11 if they were both negative. So let's try that. X minus 3, x minus 8. Well, that would give me negative 3x, negative 8x. What's inside the box is equivalent to this if I combined those. So the factored form is x minus 8 multiplied by x minus 3. And it doesn't matter what order those are in. And then I'm going to figure out, okay, well, either this equals 0, because these two things are multiplied together, or this equals 0. So I'm going to solve for x. X equals 8, and I'm going to solve for x here, and I get x equals 3. So I've got my two solutions, or my x-intercepts. Okay. And this last one, it's a little bit different because it's equal to 6. And really, we can't do that kind of trick of solving if it's equal to 6. So we're going to actually get this set equal to 0 first, so that we can hopefully solve this by factoring. Let's see. So x squared plus 3x minus 18 equals 0. So let's see. Can we find numbers that multiply to negative 18 and add to 3? So they got to multiply to negative 18. They got to add to 3. So 1 and 18, well, that's not going to work. 2 and 9, 6 and 3, maybe. Maybe 6 and 3. We need a positive 3, so positive 6 and a negative 3. So an x plus 6, well, that would give me, and an x minus 3. think so. That works. Okay. So my factored form, x plus 6, x minus 3, because those are my numbers, must equal 0. So I've changed it to its factored form. And then I'm going to say, okay, well, since it said equal to 0, what would make this 0? Or what would make this 0? Well, if x plus 6 equaled 0, x would have to be negative 6, or I can solve that. And, you know, what would make x minus 3 0? I might intuitively know, oh, well, that's when x is 3, or I can solve this and get x equals 3. So that's how we'll look at solving by factoring.